Hello everybody, my name is Shankarji. Now we'll discuss chapter 2, acids, bases and salts. An acid is a substance that releases hydrogen ions when dissolved in water. For example, hydrochloric acid, HCl, nitric acid, HNO3, sulfuric acid, H2SO4, etc. So what do you mean by bases? A base is a substance that releases hydroxide ions when dissolved in water. For example, sodium hydroxide NaOH, potassium hydroxide KOH, calcium hydroxide CaOH whole twice, etc. A salt is a stable substance which is usually formed when acids and bases react with each other. For example, the common salt, also called as sodium chloride NaCl, potassium chloride KCl, copper sulfate CuSO4, etc. Now we'll move further and discuss this topic. Understanding the chemical properties of acids and bases. Number 1. How do acids and bases react with metals? The general format is acids plus metals will give salt plus hydrogen gas. In other words, when acids react with metals, a salt is formed and hydrogen gas is released. For example, HCl stands for hydrochloric acid, Zn stands for zinc, ZnCl2 stands for zinc chloride, and H2 stands for hydrogen gas. Generally, bases do not react with metals like acids. However, there are a few exceptions. For example, when sodium hydroxide reacts with zinc, sodium zincate and hydrogen are the products which are formed in this chemical reaction. Number 2. How do metal carbonates and metal hydrogen carbonates react with acids? So the general format for metal carbonates and metal hydrogen carbonates reacting with acids are as follows. Metal carbonates plus acids gives salt plus carbon dioxide plus water. For example, when sodium carbonate and hydrochloric acid react with each other, sodium chloride, carbon dioxide and water are the products formed in this chemical reaction. And when sodium hydrogen carbonate reacts with hydrochloric acid, sodium chloride, carbon dioxide and water are the products formed in this chemical reaction. Number 3. How do acids and bases react with each other? So the general format for this equation is acid plus base gives salt plus water. In other words, acids and bases neutralize or cancel each other. Therefore, this type of chemical reaction is called as the neutralization reaction. For example, when hydrochloric acid reacts with sodium hydroxide, common salt sodium chloride and water are the products formed in this neutralization reaction. Number 4. Reaction of metallic oxides with acids. So the general format is metal oxide plus acid gives salt plus water. For example, ZnO plus HCl gives ZnCl2 plus H2O. Now we'll discuss further. What do all acids and bases have in common? Both acids and bases are electrolytes, which means that they are good conductors of electricity as they both produce ions in water solution. Next, what happens to an acid or a base in a water solution? First of all, they both release ions in a water solution. Acids release hydrogen or hydronium ions, namely H plus or H3O plus ions, and bases release hydroxide or OH minus ions in a water solution. Bases which are soluble in water are called alkalis. So, all alkalis are bases, but not all bases are alkalis. So, in this way, you can easily remember the difference between bases and alkalis. Mixing of acids and bases in water solution is a highly exothermic reaction. So extreme care must be taken while mixing acids and bases with a water solution. The acid or base must be slowly added to water with constant stirring while doing that. This is the best and the safest way of adding acids or bases to water. We should not do it the other way around. We should not add water to acids or bases, because if we do that, the acid or base might splash out and can harm us. So we should be extremely careful while mixing acids and bases to water solutions. And also, mixing of acids or bases with water results in the decrease of the concentration of ions per unit volume. This process is called dilution. If an acid or base has more concentration of ions per unit volume, then we call it as a concentrated acid or base, and if the concentration of ions is less per unit volume, then we call it as a weak acid or base, or also known as a diluted acid or a base. So this is the difference between concentrated acids and bases and weak acids and bases. There's an important note to be remembered. Metallic oxides are generally basic in nature and non-metallic oxides are generally acidic in nature. Now we'll talk and discuss about indicators. So what do you mean by an indicator, or more specifically a chemical indicator? An indicator is a substance that gives a visible sign, usually by a color change, of the presence or absence of a threshold concentration of a chemical species, such as acids or bases in a solution. For example, litmus paper or solution, phenolphthalein, turmeric, red cabbage juice, methyl orange, methyl red, etc. Now we'll discuss this topic: how strong are acid or base solutions? The strength of acids and bases are measured using the pH scale. pH stands for power of the hydrogen ion. It is a universal indicator and is used for measuring the acidity and basicity of various substances. The pH scale starts from 0 and ends at 14. The neutral point is 7. Acids have a pH between 0 to 7, whereas bases have a pH between 7 to 14, and neutral substances like water has pH equal to 7. Now we'll discuss this topic: importance of pH in everyday life. pH is very important in everyday life as well. Number 1, plants and animals are pH sensitive, as living organisms can survive only in a narrow range of pH change. For example, when pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into the rivers, it lowers the pH of the river water, and the survival of aquatic life in such rivers becomes difficult. Number 2, plants require a specific pH range for their healthy growth in the soil in which they grow. So the pH of the soil affects the growth of plants. Number 3, our digestive system is pH sensitive. For example, during indigestion, the stomach produces too much acid, and this causes pain and irritation. This is called acidity. To get rid of this pain, people use bases called antacids. These antacids neutralize the excess acid. For example, magnesium hydroxide, which is also known as milk of magnesia, which is a mild base, is often used for this purpose. Number 4, our teeth is pH sensitive. pH changes can cause tooth decay. Tooth decay starts when the pH of the mouth is lower than 5.5. Number 5, self-defense by animals and plants through chemical warfare. For example, honeybee sting, or simply bee sting, leaves an acid which causes pain and irritation. So, use of a mild base like baking soda on the stung area gives relief. Also, stinging hair of nettle leaves inject methanoic acid, causing burning pain. A traditional remedy for this is rubbing the area with the leaf of the dock plant, which often grows beside the nettle in the wild, and it is basic in nature. Some naturally occurring acids are as follows: vinegar, acetic acid, orange citric acid, tamarind tartaric acid, tomato oxalic acid, sour milk or curd lactic acid, lemon citric acid, ant sting methanoic acid, nettle sting methanoic acid, etc.